This is a capacitor, a passive electronic component. So hey guys, welcome back to another electronics video. In this one I will explain step by step everything about capacitors. I'll cover their principles, types, and applications. So stay until the end of this video. If you find value in it, please like, comment, and subscribe. Let's go. A capacitor is a two-terminal device. It can store energy in an electric charge. A distance separates two electrical conductors. Capacitors store energy by holding apart pairs of opposite charges. A capacitor's simplest design is a parallel plate. It has two metal plates with a gap between them, but many forms, styles, lengths, girths, and materials make different capacitors. But how does a capacitor work? For example, consider the simplest capacitor, the parallel plate capacitor. It consists of two parallel plates separated by a dielectric. A DC voltage source connects one capacitor plate to its positive end, plate 1, and the other to its negative end, plate 2. The battery's potential charges the capacitor. So, plate I is now positive in comparison to plate 2. In the steady state, the current tries to flow through the capacitor. It wants to go from the positive plate to the negative plate. But an insulating material separates the plates, preventing them from flowing. An electric field appears across the capacitor. The positive plate, plate 1, collects positive charges from the battery. The negative plate, plate 2, accumulates negative charges. After a point, the capacitor holds its largest charge. At this voltage, it relies on its capacitance. The capacitor's charging time refers to this time span. After removing the battery, the capacitor's plates hold opposite charges for a time. Thus, the capacitor acts as a source of electrical energy. If you connect a load to these plates, it will discharge current from plate 1 to plate 2. The capacitor discharging time is not specified. So now let's talk about the types of capacitors. There are various types of capacitors, each suited for different applications. So let's talk about the 5 most common types. 1. Ceramic capacitors. They are the most common capacitors in electronic circuits. Ceramic materials make them non-polarized, so you can connect them in any direction in the circuit. Electronic engineers use ceramic capacitors in high-frequency applications such as RF circuits. 2. Electrolytic capacitors. These polarized capacitors have a larger capacitance. There are positive and negative terminals. These components are used in power supply circuits. They smooth out voltage fluctuations, so they need a large capacitance. 3. Tantalum capacitors. They are a type of electrolytic capacitor, but they are more stable and dependable. High reliability, high performance applications like aerospace and military equipment use tantalum capacitors. 4th, film capacitors. Made from plastic film, these capacitors are stable and low loss. They are often used in audio circuits and other critical applications. 5. Supercapacitors or ultracapacitors have very high capacitance. They can store large amounts of energy. They are used in applications that require quick bursts of energy. Examples are backup power supplies and regenerative braking in electric vehicles. So now, let's talk about the applications of capacitors. Capacitors are versatile components. They have many uses. We will discuss only the 5 most useful ones. 1. Energy storage. Capacitors store energy and release it when needed. They are useful in power supply circuits, flash photography, and pulse lasers. 2. Filtering. In order to remove unwanted noise or ripple, capacitors filter signals. By nature, voltages fluctuate in power supplies and audio circuits. 3. Timing circuits. Capacitors, along with resistors, create time delays in circuits. They are used in oscillators and timers. 4. Coupling and decoupling. Capacitors can couple AC signals between circuit stages. They block DC signals. They also decouple power supplies from signal lines to prevent interference. 5. Tuning circuits. In RF circuits, capacitors adjust the frequency of filters and oscillators. So that's it for this video. I hope you've gained a solid understanding of capacitors. If you found this video helpful, please like it, share it, and subscribe for more electronics content. And as always, feel free to leave your questions or comments below. Until next time, have a wonderful day. Peace and love.